This time, instead of just walking you through exactly the same example as the text, I'm going to do things just slightly differently. Also, you'll see that this is going to build up to one of the application exercises we're going to do on Tuesday. Frank and some other textbook authors do this thing where they add a second person to the Crusoe economy. That's pretty standard, but Frank maps both Susan and Tom's production possibility frontier on the same axes. So he's got Susan's and then just draws Tom's on there. And I much prefer that students map Susan's production possibility curve in one space and scale your axes the same, but generally speaking, it's a little easier and a little bit better methodology for the next extension to map these production possibilities separately. Obviously, I won't take any points off if you map them the same, given that's the way our textbook author has done it. Anyway, what I want to illustrate is the production possibility curve for a two-person economy, and then just talk through what happens if you don't specialize along the lines of comparative advantage. You will see that it's inefficient. So let's go and do that. I've got the axes made up. This is Susan and Tom combined economy, and we graph the combined PPC with the same logic that we did just Susan's before, but now there's two factors, and those factors have different opportunity costs. I should point that out. Notice that we see that Susan's opportunity cost of nuts, remember that the slope of the production possibility curve always gives you the opportunity cost of the good on the x-axis. The reciprocal of that gives you the opportunity cost on the y-axis. Notice that Tom's got an opportunity cost of nuts of 1/2 pound of coffee per pound of nuts. That's lower than the 2 pounds of coffee per pound of nuts opportunity cost of Susan. So Tom's got the comparative advantage in nuts. Susan is going to have it in coffee. Her opportunity cost of coffee is 1/2 pound of nuts per pound of coffee, and Tom's opportunity cost of coffee is 2 pounds of nuts per pound of coffee. All right, so that's going to turn out to be important. All right, so what do we do? Remember what to map the production possibility curve of just an individual's economy, we asked, what if she put all her time into one sector? It's usually, I just do it, I'll put all resources in the good on the y-axis. All right, now we've got two individuals though. So what happens if both Tom and Susan spend all their time picking coffee? Well, Susan picks 24 pounds, Tom picks 12. The combined economy, they're going to pick 36. That's a 6. By the same logic, let's get the other easy point. Now we can't just connect the dots, so it's going to be a little more complicated. But if they both put all 6 of their hours into nuts, Susan can gather 12 pounds of nuts, Tom can gather 24. Combined, they can gather 36 pounds of nuts per day. You might be tempted, okay, we'll just draw the line. No, we can't do that, because now there's two and they have different opportunity costs. Let's start up here at producing 36 pounds of coffee, picking them. Who should we send first to get the nuts? So let's say we send one person's hour off to pick nuts, gather nuts. Who should it be, Tom or Susan? Well, Susan, to send Susan gathering nuts, we'd have to give up 2 pounds of coffee to get 1 pound of nuts. But if we send Tom, we only give up 1 pound of coffee to get 2 pounds of nuts. So if we're just going to send one person for 1 hour, it's going to be Tom. And it turns out the second hour, the third hour, the fourth hour, the fifth hour, the sixth hour, until we couldn't send Tom anymore, we wouldn't have Susan pick any nuts. She's terrible at it. She's good at picking coffee. So we send the factor with the lower opportunity cost first. It's just like my example in class on Thursday. Well, when you do this, you realize, oh, okay, well, as long as I send Tom, I've got this line with a slope of negative 1/2, right? And I just am sending Tom, sending Tom, sending Tom. Well, I can send 6 hours at Tom's time. I give up 12 pounds of coffee, but then I get 24 pounds of nuts with Tom's time. So this is Tom's segment. Tom gathers nuts, while Susan is completely specialized. And now once we've reached this funny kink on that diagram, if we want to get any more nuts, well, now we got to send Susan. We don't have any other factors. So now it's just Susan going. That segment's got a slope of -2, and we see this funny kink. There's always going to be however many people in the economy, less -1. That's how many kinks such a line, such a production possibility frontier is going to have. And then the way to show the gains from specialization is we could show the gains from specialization along the lines of comparative advantage. We could show what would happen if we, by mistake, sent Susan picking nuts, gathering nuts, instead of leaving her in coffee. If we left Tom in coffee and sent Susan instead, we'd see something different happen. In this case, we'd be sending Susan from up here, and notice that as soon as you do that, you're inside the production possibility curve. That is inefficient. So the efficiency is if we have the workers specialize along the lines of their comparative advantage.
Made with Doodlecast Pro.